Exactly, and we'll continue with Anja Vedder. She is a co-founder and managing director. Exactly. One applause, I was too fast. We'll exactly continue in the... Oh, you took the... Hannah or Anja, we need one of the clickers over here. Exactly, I'll continue. Anja is co-founder, managing director of industrial analytics, so we'll continue in the industrial area. She, before founding, gained 10 years of experience, at the end also as head of operations for a renowned manufacturer of large rotating equipment, like compressors and turbines. Very interesting. Happy to have you here, Anja, and the floor is yours.
Thank you, Merle. So welcome, ladies and gentlemen. I'm happy to be here and tell a little bit more about industrial analytics and how AI can help to optimize load balancing. So I already got a nice introduction by Merle, but I want to say a little bit more about industrial analytics. So we are a Berlin-based startup founded back in November 2017. Now we are part of the Infineon family. We are very proud of that. This is by short notice in August. And what is our goal, our target is to build AI services with engineering knowledge, because we think that real added value brings the domain knowledge, as Hannah and Anja already said that. This is really what we think makes the value out of AI, and of course that the user and the engineers using that services do know where the results come from, and is really understandable for them. So we are very much focused on energy intensive industries, like you see here in the back. You can see the power and heat station of Berlin Center. And we also for chemical plants, for example, or other utility plants, like for water, wastewater management, which I explain to you later on. So what are the most challenging topics for operators nowadays? What we can see, first of all, energy transformation. That means this is really much driven by decarbonization. And it needs to be increase the flexibility of operators, and also gets more innovative solution approaches there. Another challenge we see that maintenance and operation gets more and more data-driven, and the real added value comes or is rely on the data and expertise to get a better and deeper understanding of the process, and also the machine which are used within the process. And also a third point is the generational change. We see that experienced people are more and more getting to retire or leave the company, and the young generation follows and needs to take over all that knowledge that all the experienced people are having, and this needs to be preserved within the company. So how do we solve that challenges? What you can see here, different approaches where AI services comes into operation. That can be prescriptive maintenance. What does that mean? This is a solution that brings or comes together with recommended action to the operators that can improve maintenance cycle based on the condition of the machines, and reduce, for example, spare parts costs, and prolong the remaining useful life of certain equipment. And of course, performance optimization, that means to identify areas of optimization potential to increase efficiency and productivity of the overall plant. And last but not least, energy management means, based on the performance monitoring, it is possible to take data-driven measurements to reduce energy consumption and improve the efficiency. So what is the specialty of industrial analytics? What is really the approach that we are following? So basically, we build a digital twin of the plant, which can simulate the dynamic behavior and the correlation within the plant. The model is trained on historical data, all on our real-time data like pressure and temperature, and this all is we use first principle models. That means physics-based models for deep insight knowledge than just statistics. So I'm going now to give you a short overview of what I want to demonstrate, how we used AI to optimize load balancing. So first of all, what was the challenge about? I will give you an overview, then the potential assessment, what we did about, based on the data we get, how our approach is with optimization, and what is the potential for improvement. So what you can see here is in a rough overview of a control from a compressed air supply, which is used in a wastewater plant. And here you can see it's not that nice anymore, but it should be seen 5 compressors here on the downside that can be operated in parallel. And they feed 2 clarifiers with compressed air. And the target is really to find out control parameters to operate that compressors not only stable and safe, but also in terms of efficiency, at best efficiency. That was the target, really to optimize the operation and to use the operating data from the plant. So what are the steps to estimate the potential on supplied data? So basically there are different strategies, but typically the focus is on a stable control and operation, but this is, as I said, not at best efficiency. And the problem is that energy consumption really much correlates to operating condition, means inlet conditions such as pressure, temperature, and mass flow, for example, and that theoretical comparison process in order to determine what is good or not is necessary. And the current process control do not consider efficiency, and therefore the outcome varies very much. This is the basis to estimate a potential improvement. And the first estimate potential was 4.5%, with a possible saving per month of about 34,000 kilowatt per hour. So what is the concept and the strategy we are following here to go into an optimization? First of all, we start to build the thermodynamic model of the process and the specific equipment, and fit that model with data coming from the plant with 3 parameters, and then train the model with the present data and take care that you do not overfit the model. Afterwards, we are using evolutionary algorithms to optimize machine usage as best efficiency. And the results, of course, should be that rules come out which machine to use and with which control parameters. Very much important is to determine and check how good your model is. And this can be done that the model you train show the real parameters and based on the historical data. So that means you need to see that the operation conditions are matching to the data, to the real data coming from the plant, and then really to determine how the accuracy is of the model. After you are sure that your model predicts very much and it's really good enough, you have found out how good it is, of course, and can then let the algorithm to find out the best parameters. And here, the outcome was of a potential improvement and saving per month than more than 42,000 kilowatt per hours. This is very much a use case which I would like to or have presented today. And I'm very happy to answer any questions which may come up today or later on. You can find my contact details here. And I'm happy to talk to you. Thank you.
Thank you so much, Anja. Exactly. We have a mic over there, and someone, if there's a question, coming around with a mic. Otherwise, Anja, maybe on the note of you founded that company. Why did you see, or how did you see the need for industrial analytics? Yeah.
The need really much came from the market, I have to say. So as you said, the founder of Industrial Analytics were working for more than 10 years for OEMs in that industry. And we saw that there's a huge demand from operators and also from other OEMs to have AI solutions which have engineering knowledge embedded in there, and it is not specifically on a certain equipment, but can also be broadened to a wide fleet. And this is really that they want to be independent from certain solution providers, as we've heard from ZF, no? To say, okay, how can we adapt that to our processes, that we do not want to have a black box solution, but really integrate it in our process. And this is, fits very much to the approach that they are actually following with industrial analytics.
So that because we heard it already in the earlier talk, now that there's a question, one sec. We heard in the talk earlier that we have the challenge maybe that you need, at the one hand, the data knowledge, and then the other hand, the domain knowledge. So you kind of brought domain knowledge already with you in the founding team, but also now you have the data knowledge, and now you're kind of going back to the domain experts again and applying your solutions, yeah? Okay, then if I could have the mic, because my stage assistant is not here, so I have to, sorry Anja, come over with the mic myself. Maybe already, yeah, we had a, thank you for coming over. There you go.
Thank you. I'm just, thanks a lot for the presentation. It's really insightful. I'm just curious to know, like, where do you see the industry going towards in terms of the dependency on these solutions? Are they going to be fully dependent on these solutions? Or is there going to be a human in the loop at the decision point?
Yeah, very good question. What we see that our AI services and solutions helps very much to get to results, which are of course understandable. But what we see is that there needs to be, until now, a human being interaction to really take the decision or not. So that you have the AI who gets the recommended action, but there's still the human being saying, okay, I will follow that or not. And to trust and to follow that recommendation by the AI, it has to be really explainable and understandable. Where does it come from? Because otherwise you will never have an acceptance to follow that. But this, I think, is a development which is already going on. Within that industry we are actually in, I think there is, it is like a very, how to say, conservative business or industry, I have to say, but we see that there is more and more that need to follow that, because as I said, you need to automate processes, you need to automate that actions, because there are more and more, the situation that people needs to follow different actions within the organization, for example, and you need that help to automate processes and to keep that knowledge and really retain and preserve that, and to help people to do their daily business, of course, yeah.
Thanks. Just a quick follow-up on that. So where do you think the push towards quality assurance is going to come? Is it going to come internally from the organizations, or is it going to be regulatory driven?
It's on both sides. No? You have the quality assurance within your own company and also within your customer, and you always have to make sure that the rules you have yourselves, and you also follow the rules the customer given to you, and therefore there is an assurance anyhow to do so. Yeah.
Thank you.
Welcome.
Thank you so much. Exactly. You have the mic. Just leave it like that. No turning off. Exactly. It works normally like that with the technique. Exactly. Anja, also on the last note, because we heard you're in B2B context. I guess the process of acquiring new customers for you is quite different from a B2C context. Is it also where you gain from your already industry knowledge? Because otherwise, I guess it's harder to get the contacts, or how are you approaching new customers and new projects?
Yeah, basically it's different. The approach is of course different. The sales cycles are different. But as soon as you have references in certain industry and in certain application, it helps you very much to find new customers and to find the acceptance to show your knowledge and that the solution is working, and to adapt further customers. The idea, of course, is to concentrate on customers which are operating a huge, let's say, operation plans, certain assets, and to make it really scalable within a customer itself. So there's no urgent need to always acquire a new customer but really to have a look that the customer you are looking on, there's a potential to scale your applications.
So it's also a long-term collaboration.
Yes.
I think that's what we learned already yesterday. It's a new kind of business model. Of course, you don't have a talk with Hannah about that as well. You don't have a final product normally, but you continually improve it and work together with your customer in order to have the best experience, the best product possible. So thank you so much, Anja,
Thank you,
for the insights.